Hi, everyone. Thanks for joining my presentation on the age-old question of what time is it? For those who don't know me, my name is Christian Kaul. I've been studying myself data modeling aficionado now for quite some time because I'm really interested in learning about all kinds of data modeling, spreading the word about data modeling, reading data modeling stuff, writing data modeling stuff. So this is really my kind of thing. And for some time also, I've been studying myself. My camera is acting up. I hope you can still see me. For some time, I've also been studying myself a data structure designer. Why a data structure designer and not a data modeler? One point is like the word of modeling has taken on so many different meanings in the data world, so it's often causing confusion if you look at like models in a data science sense or DBT models. So I'm trying to push for data structures, which also captures what we're trying to create, but isn't that overloaded. And designer to really capture the design aspect inherent to data modeling. It's not that I don't know, you look at reality and you kind of like take a photo and there's your data model, there's a design aspect to it, which I want to highlight. If you want to ask anything afterwards or catch up with me, I'm on LinkedIn. I'm relatively easy to find. It's just like first name, little dash, last name. And so, what time is it? We will be looking at different kinds of time or kinds of timelines, and get through some high-level suggestions how to deal with the different kinds of time with different timelines. So accordingly, the presentation has two parts. The first one, who has the time, where we're really going through the whole terminology for different kinds of time, like who said what, isn't this all the same thing? Are those different things? And then the second part, what to do with your time, is really the more practical part. If you're doing the data warehousing, especially how do you deal with the different timelines? How do you bring them down to a manageable level for your data consumers? So first, let's look at a brief history of kinds of time. Pretty much like the founding text of this area of time in data management. This is the book from a guy called Richard T. Snodgrass. And he introduced like two kinds of time that will reappear again and again under different names and different shapes. Like the first one is what he called valid time. This is basically when something changed in reality, in real life, and transaction time when something changed in the database. So for example, I don't know if I have a biking accident and I want to make some insurance claims, then like in real life, my biking accident happened, I don't know, last week, but only today I have the time to file everything to the insurance company. So obviously, like the transaction time in the database won't be last week, but sometime this week, I guess. And this will appear again and again in various guises under various names. So we have the SQL 2011 standards where they try to formalize this kind of stuff a little bit, and they used probably like the most misleading terminology and the most confusing definitions of like all the examples here. Like application time and system time is already kind of unclear. So my understanding is that application time is basically this real life change time, and system time is like the database change time, but like it's not really clear from the terms, and they are a bit like confusing, and like the definitions are just plain horrible. So like a period whose name is system time is also known as system time. This is not a definition, right? This is, but from what I understand about the intention, this is basically the same what let's go back. Same what Snodgrass said, trying to standardize it and kind of making it completely confusing and muddled in the process. So it doesn't seem to me that the standard has gained a lot of traction, but still I wanted to add it for sake of completeness and yeah, just to see that you see what it looks like. The next one it also goes in the same direction. That there is a very detailed book by Chris Date and some associates of his. Maybe you know Chris Date, like he's like one of the pioneers of relational the relational model. So there was caught, and pretty much Date was the next person to work on this. And they have a book about this, and there they call two different kinds of time: stated time and log time. But essentially it's pretty much the same thing again. So this is when something was true in real life. This is when it was true in the database. Only recently I stumbled upon the terminology that Martin Fowler uses. You might know Martin Fowler as a programming guru, prolific author of all kinds of books on programming and also on data stuff. And he uses for pretty much the same concepts actual time and record time, which I think it's pretty understandable and like the first set of terms that I find kind of helpful, like actual time when something happened in real life, record time when it was recorded in the database. So he says it himself. Yeah, people kind of found the terminology for the two kinds of time confusing, and actual time, record time pretty much captures what these kinds of time are without being too confusing or too technical. So let's see for the next one. This is also like a quite sophisticated, quite technical book on time and databases from a guy called Tom Johnston, and his terminology for bitemporality is also something that has gained some traction, but I guess not so much in the wider world. He calls the two kinds of time: state time and assertion time, where state time is when something is the case in the real life, so about like the state of things in real life. He thinks it was the least misleading term. I don't know about that. And assertion time is basically again when it's true in the database. Yeah. Where it gets more interesting is towards the end of his books, he goes to three kinds of time. And this is where it gets interesting, because if you look at everything that we had before, basically it was everything the same, just different words for the same kinds of time. And this one is where it gets interesting. State time is when something happens in real life. Speech act time is a generalization of assertion time. Basically, when anyone makes a speech act, when someone says, "Yeah, this is the case. This is not the case," assents to something, dissents to something. So this is really like a generalization of what Tom Johnson called assertion time before. And then this inscription time is, yeah, basically again when something is stored in the database. And I think this is less misleading than before when he used like assertion time for storing the stuff in the database. So this is something to keep in mind, these three kinds of time, because there's a pattern here. Pretty much everything you see in this presentation, pretty much all the time terminology in the end, you will be able to map on these three time dimensions we will see in a minute. There's somewhere a bit more exotic. He's a German, I think, Philip Salvesberg. He has valid time, which is pretty much what we see in other authors as well. Transaction time is also kind of clear time of change in database. And then something he calls decision time, the date and time a decision has been made, which is interesting, but maybe, I don't know, a bit too special.
Yeah.
But just for the sake of completeness, I wanted to include him here. If there is something that's interesting for the whole group, you feel free to interrupt me.
Sorry, Christian. And that's a great time to interrupt. That decision time. Is it a decision when I make a decision, or when the data is changed, or the transaction is approved, or what? I'm still a little bit lost about what
understanding is, again, if we go to the insurance example, for example, I have something in real life. I don't know, my insurance policy goes from this date to this other date. That's the time when like this is recorded in the database. Decision time is probably when someone signs or approves the contract.
Right. So if I have a claim, I submit the claim, and it may take a while, and then when it gets approved and everything gets passed, and that's the decision time for approval.
Yeah.
Okay.
Yeah, and we get to Michael Brackett in a minute, who does this in a more sophisticated way. He distinguishes like these 5 different time points, and this is really interesting because there you get into some kind of like workflow or process flow where you can see like the alignment between the different times and the different like steps in the process. The business change time is when something like changes in the real world, basically. Organization notification time is when the organization becomes aware of this change. Again, if we go to the accident example, this is when the accident happens. This is when I send my email or letter or whatever to the insurance company. Then the organization receive time is when they get my email, letter, whatever. Change entry time is when some clerk enters all the stuff into the database. And then change availability time is for example, when all the stuff is processed and it's accessible in the data warehouse for analytics. And this is there's a series of books from Michael Brackett, who I think is a Dharma personality, if I'm not mistaken. And he has a series of books with techniques about data topics, and this is probably the most sophisticated like time terminology I've found.
Right. Christian, there's one question from Gabriel. He asked, decision time, is that equal to the date and time when an assertion was decided upon as being true or false? I think we may have lost Christian. Hello?
I'm back, right?
Did I get lost or were you lost, Christian?
No, I got lost, I guess. So
okay. So
yeah,
the question I have from Gabriel is decision time, which is on your previous slide. It says, is that equal to the date and time when an assertion was decided upon as being true or false?
No, I would have to get back to the original blog, but my understanding is really this is when some kind of meaningful decision is made in real life, like something is approved, something is signed in real life by someone.
So it doesn't matter on the outcome, it just matters that's when we made the decision.
Yeah.
Gabriel, does that answer your question?
Yes, thank you.
Yeah.
See. Yeah, so we were at the Michael Brackett kind of terminology. Like I said, this is really nice because you see like the different time points of the connection to like a process or a journey that the data makes, basically, for something happening in real life. People notifying you about it, you noticing it, someone processing it, and so on. Then there's the terminology from Lars Rönnbeck of anchor modeling fame, who's a good friend of mine and a frequent speaker at the Knowledge Gap conference. I really can warmly recommend his work. The terminology he uses for anchor modeling is changing time, happening time, and recording time. So recording time is again this like change in the database. Changing time is when a value changes like in real life, within the domain of discourse, like he formulates it here. Happening time is kind of a special case, the moment or interval at which an event took place in the domain of discourse. So not sure. To be honest, I'm not quite sure about this kind of thing. Why we have this distinction? Maybe this is something I have to run by Lars to better understand it.
Yeah.
And then again, like he's also the person behind it, transitional modeling, with this, which is a new modeling technique that allows for changing, varying, conflicting kinds of information. So it's more general than what you see usually, like in the database. When you put something in the database, it's true, and transitional modeling allows for opinions basically, and clarity, reliability. So it's really interesting. But the point for this talk is there are 2 kinds of time. There, appearance time, again, pretty much this is the real life change. And assertion time, when someone says something about something. This is basically what Tom Johnston from earlier called the speech act time.
Sure.
And so we're almost there. I guess you're really starting to sense the patterns here. Peter Bellas, who's also a regular at the Knowledge Gap conference. We also had him at my meetups. He distinguishes between 3 dimensions of time, again, like business validity, something happening in real life, like inscription time, which is the database change time in the operational system, and load time, which is the time in the data warehouse. So you can see he comes from a data warehousing background. So basically he distinguishes 2 kinds of like inscription time, or 2 kinds of technical time, like source or operational system and data warehouse.
Hmm.
And then we're almost there. Patrick Huber, who's also the Data Vault author, that he's written like a really big book on Data Vault called Data Vault Guru that you might have noticed. He distinguishes between applied time and load time, which basically are again the technical timelines, like the load time in the data warehouse, and like the time that is attached to whatever package of data comes into the data warehouse. There's also some writings by Dan Lindsay, the creator of Data Vault, that mention applied time. But to be honest, I couldn't make that much sense out of them. It seemed to me like for him, applied time is everything and nothing. So I decided to leave it out of this comparison until I get some more information or some better understanding. Yeah, we're almost there. Some of you might be aware of Kafka, a solution for dealing with streaming data. And they again distinguish 3 kinds of time: event time, which is formulated in a technical way, but from what I understand is in principle when something happens in real life. Like this is, for example, sensor data, like a sensor registers the temperature at a certain point in time. So yeah, it's basically when something happens in real life. Ingestion time when like Kafka gets it, processing time when it has processed it. So again, like technical timelines. And finally, like if you see all these terms, we have really quite a lot of terms. We will see the table that Howard has shown before again in a minute. Like there are a lot of terms, but most of them are not that different. Like we have this what I call like the first time dimension here: valid time, application time, stated time, actual time, state time, business change time, changing time, happening time, appearance time, event time, which are basically all pretty much the same. Something happens or something changes in real life and in the real world. Then the second dimension, this is the thing when someone makes a statement about something, like this is true, this is not true, I assent, I dissent, whatever. And again, we have like many words for this, but most of them are synonyms. Some of them are special cases like assertion time, speech act time. Then some of the special cases here: withdrawal, assent, dissent, notice, decision time, organization notification time, organization receipt time. And the third one is like this is the technical dimension. So when something is stored in the database or other means of storage. So this transaction time, system time, log time, record time, inscription time. Some special cases with like change entry, change availability, recording time, load time, applied time, again, special cases, ingestion time, processing time. And if we look at this, so like this whole zoo of terms becomes a bit more manageable. So we have these 3 main dimensions. What I've called appearance time here, something happens in real life. Then Rebec style assertion time or speech act time, when someone says something about something, and recording time, like this technical dimension. Again, I guess we could discuss all day like which term to put here. You could also argue to put like inscription time here or record time here, but in the end, like these are pretty much synonyms. So I guess it can go either way. Here, as you can see again, like there are several synonyms for appearance time, several synonyms for recording time. Like the second dimension is kind of, I would say, underappreciated a bit. There's not that much literature about it, not that much alternative terminology, but those are pretty much the bedrocks. Like dimensions 1 and 3, they're also part of the SQL for the 11th standard. But 2 is something where it can get really interesting. Also, if you look at the special cases here, you have this like Johnston assertion time, withdrawal, assent, dissent. So you can really see there are all kinds of statements people can make about things or events that are interesting and that might warrant storing them in the database with a time point. Again, like the decision time, organization notification time, organization time, these all play in here. Of course, there are also all kinds of special cases for technical timelines that are probably especially interesting for the data warehousing folks, where you want to track like what happens in the source systems, how is this the data processed. So this can be like the change entry time again when someone really types something in the operational system, the change availability time when the data is processed and available for analytics or whatever technical intermediate steps. But also potentially for the appearance time, it might be interesting to look at these special cases, but I guess in most cases it's pretty clear something's happening in real life. You have this, whatever you call it, actual time, appearance time dimension. So some more questions about actually, like these different kinds of time, yeah.
Sorry, Christian. It actually looks like that change entry time would be very valuable from a timeliness data quality dimension in terms of picking up latency and how long a record takes to get into the analytical environment ready for analysis.
Yeah, definitely. So this is really something to look at. Yeah, timeliness and how well your system works, like the difference between like the change entry time and then the change availability time for end users. For yeah. And also potentially something to look into is the difference between like something happening in real life and then the change entry time, because this can also cause all kinds of havoc if you have like this kinds of like later arriving data.
Yes,
when something happens that has a financial impact and you only entered in the system like month later, maybe in the next fiscal year, this can also cause all kinds of issues. So it's also something to look into, like the difference between actual time, appearance time, whatever, and change entry time. Okay, so we've looked at all these different kinds of time. We hopefully brought them down to a more manageable level with these 3 dimensions of time. Let me have a quick look at the chat before I get into the second part.
Christian, I'll look at it and I'll notify you of a question.
Okay, good. Then I'll continue with the second part. So the second part is really some high-level suggestions what to do with your time, dealing with these different kinds of time in a data warehousing context. The first point is how much time can you have? So if you're looking at the operational systems and the transactional systems, do they store like appearance time, assertion times, their own recording time? They definitely should, so that it's clear when something happened in real life, when something was known to the organization, when something was recorded in the system. So if not, why not? Can the change? This is really something. It's like a common that operational systems update in place, and this makes kind of makes sense. You don't have like limitless amount of storage usually, but still they shouldn't be completely timeless. It should be understandable, like when something happened, and only then it's really possible to build a sensible history in the data warehouse if you have like some time points to work with. The second aspect, now you're on the data warehouse side, how much time should you have? Do your stakeholders, the people using the data warehouse, the people doing analytics, want to know appearance time, assertion times, operational recording time, data warehouse record time, and so on? If they want to know them, why do they want to know them? If not, can that change? So this is kind of to not overbuild your solution. You should make sure that you give people the kind of time they need and not more, because going like bitemporal or tritemporal can be really confusing. So you should avoid that at pretty much any cost, to be honest.
And Christian, would I be correct in that question of yours? So if so, why? That's probably what you'd be calling your dimensions, or role playing on your dimensions, to ensure they understand what it means, because they probably get confused with all the synonyms in the different areas. So I'm assuming when you say, okay, if you want this, why do you want it? And then you may change appearance time to be something that they can relate to from a naming point of view.
Yeah, definitely. If we go back to the slide, you definitely should to think about when you start doing like workshops with stakeholders or whatever, like what to call the time dimensions, and also have some examples ready, so to make sure that people know what they ask for or what we're dealing with. Yeah, definitely.
Then there's a question from Di Joseph. How important is the time zone in which the event takes place, and do we track that?
I would say it kind of depends on your organization. If your organization is very local, so basically it's one city, one country, one time zone, it's not that critical. But as soon as you like go across time zones or cover like different data sources from different places, it's very important to like use UTC and or store time zone information, because again, this can cause all kinds of problems if you're not dealing with it properly. I remember very early in my career was working for a company that was dealing with like meter data management, so with water meters, and like every year there was one night where they had all kinds of weird issues because like the server went to daylight saving times and the meters didn't. So they had at the end of daylight saving times they had this duplicate hour.
Right.
And they had all kinds of errors there. So this is really something to take into account. Yeah. So if possible, store in UTC. If not, there has to be some awareness about the time zones. So if we think back to the two previous slides, with like how much time can you have, how much time should you have, these are really the two aspects to think about. So storage versus presentation of time. You should store all kinds of time you can get, basically. Definitely all kinds of time you need for regulatory requirements and the data warehouse recording time. So you have at least one timeline that doesn't break, one timeline that you control. Lars Rönnbeck, in some of his writings, distinguishes between like primary timeline and documentary timelines. And basically the data warehouse recording time is your primary timeline. And then the others are your documentary timelines usually. And then the presentation aspect, present as few kinds of time as possible, the kinds of times needed and not more, and wherever possible, like real life kinds of time, not just like poorly technical timelines. So when something happened in real life, or as an approximation, when someone entered something in the operational system, usually like the purely technical timelines are not that you use for your users. And what kind of also helps if you have some kind of terminology for the different what I call view modes here. So in many cases you want something like now. So basically you want to show things as they present themselves now. So what do you think now that things look like now? There are other cases that might be helpful, but like now is probably your default. So in most cases, people will want to see what we think now that things are now. There can be something that's interesting now then. So some kind of snapshot or whatever. What do we think now that the situation was at a certain point in time? Then what's also sometimes helpful is like then. So as posted views where assertion time and appearance time are pretty much the same. So some kind of like transactional log, what you thought at the time things were at the time without any updates. And what also sometimes can be interesting is like then now. So what you thought the current month would look like at different points in time, for example. What sometimes also becomes interesting, especially if you're thinking about your data marts, about your dimensions. Unitemporal views that are either like fixed variable or variable fixed. So fixed variable means the assertion time is fixed. Usually it's what you're thinking that is the case now. And then the full appearance time history. So basically history of real life changes as it presents itself now. So the history that we think happened in real life now. And the variable fixed is pretty much this forecasts thing. So we have a full assertion time history, but a fixed appearance time. So the changing forecast for a current year, for example. And we know, like, with everything that happened in the past 2-3 years with like COVID and monkeypox, Ukraine, whatever, like that this can also be valuable to like compare like forecasts over time. So what we thought 2020 or 2022 would look like at different points in time. And then, of course, it gets more sophisticated, like bitemporal views or even tritemporal views. And like, if this isn't really like part of the DNA of an organization, usually you won't get anywhere with like presenting bitemporal views or even tritemporal views to your end users. They just will find it too confusing, too hard to work with. There are some special cases, again, insurance maybe where like this bitemporal kind of view might be helpful, but in most cases, non-temporal is fine, maybe unitemporal, but don't go beyond. So I think we're almost done here. Just some more like general tips. Howard, you already hinted at this. Some kind of like freshness indicator should always be there. Like for the people using the data, it should be clear how current the information is, how fresh the data is. And then just use the simplest view that still works. Pick now, whenever possible. It's pretty much everyone understands that it works for most of the cases. I've even seen data warehouses where they basically didn't really store the history. Like the whole data warehouse was now, which is kind of in violation of the Inman criteria, but still it worked for them. And like the one glaring exception I would say is if stakeholders want to be able to recreate past reports, then you definitely should make sure they can do that, because if you don't do that, they will pull the data to Excel and create their own Excel file archives.
Yeah.
Like I've been involved with something like that where quarterly reports were sent to doctors about prescriptions and stuff like that. Then sometimes like recalculations or rule changes came and like we were updating the data, and still it was very important to still have somewhere like the original data that was sent out to the doctors and not just like the most recent calculations. Just think about like the doctor calling the regulatory agency and asking about some numbers in their report, and you don't have these numbers anymore because you have overwritten them with the later ones. This shouldn't be the case. Any more questions?
Yeah, I have a question here in terms of from a time series type of database management system where there's constant forecasting with similar data, but in some cases coming out with different answers. So I'm assuming that variable, the one that you had on the previous slide, where I could have multiple people doing forecasts at different times, and then we need to understand sort of when those forecasts happen. Is that an application to it?
Yeah, this is basically it's very similar to this one, but like
yes,
where fixed changing forecasts. Yeah. Okay, so let's see. Yeah, this is if I haven't like completely scared you away from this topic. There's some interesting further reading. There's like Peter Ballister that I've mentioned before, who has a nice series of blog posts on temporality in the data warehouse. There's the Michael Brackett book that I cited, the Tom Johnston book, which is, yeah, it's not an easy read, but if you want to dig deep, it's definitely interesting. I have a series of articles on modern data warehousing with DataWart, like parts 2 and 3 deal with this time terminology. There's a Richard Snodgrass book, which is available for download online. There's a nice practical white paper from a guy called Roland Voss, called A Brief History of Time for Data Vault. And there's a lot of different publications from Lars Rembeck that deal with this different aspects of this. There's a transitional modeling paper, something about temporal dimensional modeling, where he looked at the different kinds of slowly changing dimensions and the issues that they have, like both from a logical perspective and from a performance perspective, and some alternatives. So this is really, really interesting if you're looking into data warehousing, dimensional modeling. there's the bitemporal version of anchor modeling, and there's a really great summary article on time in databases that basically, if you read one thing from this list, it probably should be the time in databases article. So, and I think this is pretty much it from my side. So, any further questions?
Christian, there was. I saw Don put his hand up and he put it down. Don, was your question answered, or is there something more you'd like to ask?
No, it's just been a really interesting presentation. I guess I was just going to add that if you are doing forecasts using data with different temporality, it's always really important to be able to then timestamp not just when the forecasts were done, but also record what underlying data was used with what temporality. So, for example, if you're using financial market data, that might have specific timestamp for when it was recorded, but a different timestamp for when it was when there was so when it was recorded from the source, but when it was might have been loaded at a different time by another agency, or sometimes you have data you have an initial quote that's at a different time to the settlement of the transaction. So you might have different linkages in a chain. It might be a quote, then a transaction, and then there was settlement of the transaction at a different time, and having the ability to have all of those recorded, but then also when you do produce forecasts or use it in modeling, knowing which versions of each of that data you've used, so that you can, for recording purposes, but then also the ability to be able to interact with data that has a specific timestamp. For example, on financial data where you've got, say, different time zones, knowing exactly what time zone the transaction took place in, then you can change the modeling that you do by changing the time zone that applies. So it's a really big, important data management challenge, but then also, standardization of the type that you've been describing is incredibly important, so that everyone knows exactly what the different terms mean in practice.
Yeah, definitely. There's like a big data lineage aspect to it. You don't just want to know like where the data comes from, but also like from when the data was basically.
Yeah.
So what I did when I was redesigning this medical reports system, I made sure that it's clear when I create a round of reports that it was clear, like, okay, we took like from this provider, we took like this data set with this timestamp, from this provider, this data set, this timestamp, and so on. That it was always clear, not only like when the reports were created, but also like what time slice of the different kinds of source data was used. So I guess your question goes in a similar direction. I've seen something in the chat about activity schema. Actually, I'm currently looking into this because it keeps popping up on LinkedIn, and I don't really have a fully formed opinion of it yet. It looks interesting. I'm not quite yet sure if it like works as advertised, both from like a scaling perspective and also from like the messiness perspective of real data. If you have all these kinds of tracking data, it's not always clear like are the timelines clean? What kind of timelines are we looking at? So I don't have a fully formed opinion yet, but I'm looking into it.
Thank you. Eke, is there a further question on that?
No question. It's just it was interesting. I attached the link to the podcast where the narrator, they were talking about the technology and the methodology. And they were saying that, yeah, it's kind of interesting. We are talking about the activity schema to the technical people. And they're like, why would you do that? And we are talking to the business people. And they're like, oh, you guys don't do that? So I found it kind of interesting, like the way they express it. It seems that like the business side, that's as per the business, that's how all the activities or how data warehouse should be modeled. And as for the technical people, it's kind of a new concept. Yeah, I found the podcast interesting. Highly advised.
Yeah, like I said, I'm currently looking into it. I also read a blog post from the guy behind this, Like I said, I have to look more closely, because again, this block, some of the arguments for it, for me, it looked like a lack of understanding of what's already there, because it like there was a discussion that you basically always have to load like the full derived data set, because you don't know if all of the source data sets are like of the same freshness. But there are ways around this that, for example, Roland Voss describes, where you say, okay, if you have like different feeds from tracking, then just look at the oldest one and also load them then from all the other feeds just until the timestamp from the oldest one, to make sure that you have a consistent picture. So I'm not quite sure if this works as advertised, but I'll look into it and get back to the topic.
Thank you.
Christian, there's a question from Lex Dendup. It's on the chat. It's quite detailed. He's asking, where does this fit into your model? Can you see the question?
Yeah, I can see it, but I'm not quite sure if I get it. Maybe you can describe it in your own words.
Lex?
Yes, sorry. Yeah, so when you think about time, in a project perspective, you have to deliver certain deliverables. You have a target time that those things need to be delivered, and an actual time when they actually have been delivered. And maybe there's a revised time when the deliverables have been reviewed and approved or disapproved. And there's a certain deadline time that you need to adhere to. So you can do that for a start date or a start time, but you can also do that for a review date or review time, and then validation time, approval time,
True.
event time, interval time, etc.
So I would say what here comes into it are mostly, let me get back to them, like the first two dimensions. Basically, there's like, you have your like real life timeline, and then you have like the basically the different assertion, speech, export, whatever. So at the start of the project, you're saying quite confidently like the project will be finished by the end of June. But then your I don't know, your superior says, yeah, sure, that's what you're saying now. Just make sure that you're done by the end of September. This is like the hard deadline. You can't take longer than that. And then it's already May, and you see June is critical. Maybe it will be August, and so on. So this is really the interplay between the first two timelines, I would say. So when you think something will happen in real life and when it actually happens.
Okay, thank you.
Any other questions? I know there's a question from John outstanding, but that seems to be related to the previous discussion with activity-based modeling. Is that the same as event-based modeling? Christian,
like activities, this schema is some very particular way to storing event data, but you can look at the publications from, I don't remember the name from the guy behind activity schema, but I guess the name is in the podcast.
Yeah. Great. Any other questions for Christian? Oh. Christian, thank you. Thank you very much for the presentation. It's been great to review all of it. We've got a new message. Okay. So thank you from our side. We really appreciate the summary of time. I'd love to know, Lex, anything from your side, sir?
Oh, there's lots of things that I would like to discuss with Christian, maybe a different time, but not for now. Thank you.
Thank you very much.
So you're welcome. Thanks for having me. I'm happy that my voice carried the whole presentation. I wasn't sure about it at the beginning. So thanks.
Thank you very much. Thanks, everybody. Have a fantastic time and great evening or morning for Mark. Cheers, Mark. Have a good
Bye,
one.
everyone.
Thanks, Christian.
Thank
Thanks,
you.
Howard. Yep.
Thank you.
Thank you. Bye.